So, welcome back to the Installer Plaza, and sponsored by our very good friends at Valent. And we're having the first great debate of the day, and the topic is the importance of hydronics when designing heating systems. Lots of headlines and attention being given to the heat pumps, hydrogen and heat networks in the race to net zero. We're going to discuss some of the important techniques that the installers need to know about, including heat loss calculations, pump sizing, radiator sizing, hydronic balancing, pipe sizing and more. And I've got a fantastic panel joining me here on the plaza. I'm going to ask them to introduce themselves one by one, starting with the nearest to me.
Hi everyone, I'm Aimee Holloran and I work for Samsung Climate Solutions on the heating side. My background is I was an installer, so I was on the heating side and then moved into air conditioning.
Thank you.
Hi there, my name's Leah Robson. I run a company called Your Energy Your Way. We install solar panels, heat pumps, home batteries, the whole house thing.
Morning everyone, my name's Rhiannon De Wreede. I work for Warmur and we use software calculations to help consumers and businesses figure out what's going to be the best renewables.
Good morning, I'm Richard Burrows. I'm from Mid Wales Plumbing and Heating Supplies, and we supply heat pumps and hydronic solutions for plumbing and heating installers.
Rhiannon, I've got to start with you. Have you been supporting Taylor Swift this week? Looking at the jacket you've got on there.
I wish I could afford tickets to Taylor Swift, David.
Brilliant. Well, welcome everybody. And I'm just going to throw out some sort of comments, questions to you, and feel free to pick up as you wish. Okay, I'm going to throw this first one out. I don't want it to be controversial. How well have heating systems generally been installed in the UK? Who'd like to pick that up first? Go on, Rhiannon.
Well, no, I was going to say, I think, that is a bit of it's a tricky question, that one, but I think the heating systems that we've had installed have worked for the technology that we had at the time. Now we have different technology. Those heating systems aren't quite up to, the standards that we need. So, whether they're bad or not isn't really the question. The fact is they used to work, now they don't.
Aimee, go on. I can see you
Yeah,
chomping at the bit.
I was just going to add in, I remember when I did my apprenticeship and we did longhand heat loss calculations, and I think most installers reverted to either a Mears calculator to do a heat loss calculation or the BFW factor, so big window, big radiator. And obviously with heat pumps, we need to factor in the lower flow temperatures and things like that, the pipe sizing. So I think it's quite easy to forget from your college days the sizing and things like that, because we've had rule of thumbs and tools like that to do the design. And if we look at our installs now, I think 28 million homes, 15 million of those are combis. So we've been taking out system boilers and open vent systems and replacing them with combis, and with heat pumps we need to revert back to that kind of traditional system boiler setup.
Right. Rich, do you want
I think the reality is that systems have been rubbish. Is the reality. Yeah, so there's no point holding back about this. So we've had things way too easy for way too long. So combi boilers kind of broke the system. So where we used to do in the old days, proper heat loss calcs to a certain standard, whether that been Mears calculators or what it would have been, I remember actually at Worcester Bosch one time when I was doing it, and we were doing our energy efficiency level 2 or 3 or whatever it was that they all forced us to do, and we had to do the whole house sizing calculator, which oversized it by about 50%.
Right.
So when we're in an industry that allows and promotes that kind of standards, obviously a lot of boilers got put in badly. So we're in a position now where we try and now retrofit heat pumps to that exact same system. They're not going to work. So we've got real big problems in most retrofit market, I would say, where you go to fit a heat pump, it's not always just going to be a bolt on and it works outside the box.
And I guess the consumer, the customer at the end, they say, well, why is this? Why can't you make it work?
Yeah, I mean, the biggest problem with consumers is they don't know anything, okay? They know what they want and they know what they want to achieve, but on an engineering level, they don't really understand why you've now got to start putting 28 mil, or bigger pipe work
but
throughout
you people
their
are the
house.
educators, I guess. You're the sales force for the manufacturers, if you like, and you're the educators too. You've got like a trifold job going on.
I mean, I think the biggest challenge for the guys out there is that the value in some of the guys out there that do the high levels of work, that when they go to cost these systems, they're always under the premise that when they've got the Eco4 schemes going against them, and they are doing it for the bus grants, but those systems are nowhere near the level of detail or quality that like some of the installers out there provide. And then when you put bus grant plus another 5k, 10k, whatever, then those are deemed as expensive systems. But in reality, they're not. You're getting what you'll pay for.
Yeah, Leah, did you want to add anything to what we've heard so far?
Yeah, I think as a business owner, as opposed to an installer, I'm loath to sit here and say all the systems are rubbish. You can do that.
Yeah, I'm not asking you to say that, by the way.
No, you carry on. But I think what we need to be aware of is that there are just so many tools coming onto the market now. Yeah. So whereas in the past you either had a longhand heat loss calculation you probably did on a piece of paper, or you kind of went, well, actually, in real life, I can't do that. I'm just going to go with a rule of thumb. Now we're seeing loads of tools come onto the market, and you've got like this massive computer in your pocket that can do a lot of this stuff. So it actually enables people to be more accurate and to actually do the proper calculations, because it doesn't take 3 hours sitting down with a piece of paper and a pencil.
Right, but it's interesting because, looking at here, pipe sizing, emitter upgrades, accurate heat loss calculations, more associated with heat pumps, but benefit all heating systems. I just wonder, but the price of those being bundled into heat pump quotes, which makes a swap, compared to a company, more expensive. So how do you overcome that?
So it's that customer education piece, really.
Do you have the time to educate the customer, though?
It takes a lot of time. Yeah. I mean, it is very time-consuming because you're having these conversations about a whole new type of heating system when they thought you were just coming in to kind of swap one box for another. So yeah. It's definitely a big challenge, and one that takes a certain kind of installer, I think, to be able to get that right.
Aimee.
I think as well as for the consumer, you explaining the value in how the system should operate at its best. And I think with a boiler, you would, in a day, normally do a boiler swap, and then you would just leave it running. And part of that journey is explaining to customer the benefit of lowering the flow temperature, having a 3 degree setback than a 5 degree setback, and not letting the fabric cool down. It's about all these things and educating the consumer, because these principles that we talk about, lower flow temperatures, they're the same for boilers. You run the boiler at a lower flow temperature, it's more efficient. So yeah, us.
Well, I class myself as a consumer, definitely not an expert. So I just want to know, when I turn on the tap, I get hot water. When I turn on the heating system, I want warmth. So it's a difficult job to do, isn't it? Because actually, I trust my installer. He's the person I've used since we moved into where we are. And so my biggest question always to him is, well, if it was your house, what would you do?
Yeah, I think one of the really strong tools is to have other customers, and the majority of our customers absolutely love to tell anyone who wants to listen about their heat pump. So if you can say, look, come and speak to X, they will tell you that their house has never been more comfortable, it's never been warmer, and it still costs them the same to run as their gas boiler. That's actually a really good sell. So we find getting other customers to sell to customers works really well.
Testimonial. Rhiannon.
No, yeah, absolutely. And I also think when I was working with an installer, that is exactly what we used to do. But customers do need that hand-holding, and because of a lot of the bad press that's been out there, they really want that confidence and that trust.
It's a stress purchase.
And then you want to get away from that. I mean, the other thing that we could do potentially is to have, a house heat loss or a heat pump passport is one of the things that we offer at Warmur. And if you have a heat pump passport, that is information that you can have with emitters, sizing, pipe sizing, and all that kind of stuff. You don't necessarily then have to go straight into an install. You've got all that information, you've paid for that, you can hold on to that, and that's part of the education process. And then when the time's right, because timing is everything, then you can go decide to get which renewables you want. And I think for customers and I think for installers as well, us having those conversations should save people like Leah a lot of time.
Right.
Well, I said a little while ago, so it was about, I think it was last year or the year before, I actually said that what we should do in the UK is actually have all the houses in the UK heat lossed. Yeah, just have that done. Yeah, so have the government pay for that. Because in the longer run, if you then know what the heat loss of the house is and it's done to an equal standard, so across the board, then actually, and a level of detail goes into that as well. So not anything like there is at the moment with the the EPC drive-bys and stuff like that, because none of that's useful information. When they're actually accurate heat loss, and the guys are very, very capable of doing accurate heat losses, then if we had a standard and it was all done to that standard, and you knew when you rocked up that you only needed that size boiler or heat pump, it wouldn't matter what the technology was, but you could size it accurately without any prior knowledge. So as long as you can then get the boiler right, so as long as you can rock up to your merchant and actually order the right product, order the right pipe size and things like that, then it would be an easy transition, right?
Yeah.
We need to be able to trust each other's heat loss. Heat loss gets done repeatedly. And, you know, for consumers as well, they'll say, well, I've had 3 different quotes and 3 different heat loss. We need to figure that out.
Yeah, and that's some of the problem with it, is that like with the elements, so when you go and do a heat loss and you have the elements of the building, so like the outside wall, the inside wall, air gap, and the makeup of the wall, some people get that wrong. So when you assume, especially the people that assume that a cavity wall installation's been done because it says so on the EPC, and then it turns out it hasn't been done.
But how do you overcome something like that? Because it's impossible.
Well, it's very difficult, but if you've got a standard, or at least the standard goes to the point at which, you know, some people actually go to the point of drilling a hole through a wall.
Well, I was just going to say that's the only kind of way of doing it. I mean, in that, you never know. In 8 days' time, the next government might bring it in as standardisation. Yeah, whatever.
I was going to say the other thing with heat loss calculations is there's only other variables on the heat loss that can make it change so much. So air permeability, what setback you're putting in, what thermal bridging you're putting in on that heat loss. And I think if you had 3 separate people doing a heat loss calculation, all 3 would come out slightly different. And I've seen the companies out there now that they'll go in and they'll put a heater in a property, they'll seal it up, and they'll actually test the thermal capacity of the building. So it is tricky when it comes to heat loss, because it's only as good as the person inputting the data into it.
Yeah.
I think one thing we really need to do is to close the feedback loop. So as an installer, I'll go out there, I'll do a heat loss, we'll fit a heat pump. We go back next year, we see how well the system's running, we see that it's got a good cop, but we don't necessarily know how accurate we were with the heat loss in the first place. So if we could have some way of knowing without having to fit kind of expensive monitoring on every single heat pump, we could just know how well we'd done, then because you can't improve anything that you don't measure. So if we were constantly getting feedback after a year saying, actually, you were a bit over there, you were a bit under there, that would really help the industry.
But how would that happen? Because
I can probably add that from a manufacturer's point of view. So we're developing a tool called EHS Cloud. And what you can effectively do is you can fit a Wi-Fi box. Some of our products are already Wi-Fi enabled. And what you'll be able to do is to remotely access as the installer, and then you can have tiers in which you can escalate it up to us. So you can then look at the customer's running costs. You can look at how they're using the system. You can alter field set values.
But who's going to have the time to do that with however many customers you might see in a year?
I think as an installer, like servicing is something that is missed out on within our market, because we've got a shortage of installers. Most installers are concentrating on the installs. So an installer should also be looking at the service of that product from a longevity point of view. And part of keeping warranty up together for most manufacturers is having it annually serviced. So if you can remotely dial into that product before the annual service or when the annual service is due, you've got that insight into the product. You can see how the compressor's been running. You can see before you go out to the customer what you need to do.
Which is going to save time on the job itself and save the customer money ultimately, and so on and so forth.
And prolong the life of the heat pump.
Aimee, that's really encouraging that you're developing that. And I've been speaking to a few people about controls and monitoring this year, actually. It's become like much more in my interest. And there's a few, I mean, how do you feel about sort of third parties who are doing this and that compatibility?
I think there's lots of companies doing lots of different things, and we've got our own controls. A big thing within Samsung is Smart Things. So Smart Things is an ecosystem that connects products. It's an open platform. We've got over 300 brands on there now, 3,000 devices, and it's about connecting technology. And I think, for me, heat pumps are at the stage now where, as an efficiency point of view, where we are with condensing boilers. But it's about integrating that in with other technology like PV and battery, and utilising the best tariffs. There's obviously a lot of tariffs coming out on the market now for heat pumps. And what Smart Things does is control all, it creates an ecosystem within your house and optimizes based on when you've got excess PV, when you've got the cheap tariffs and things like that. So I would say we are very open to working with other manufacturers and working with other technologies on the market, because the whole house approach is the best way.
I was going to say, how important do you think it is when you're looking at controls to the efficiency of both boiler and heat pump systems? Obviously very important.
Yeah, it's not just controls though, it's the system.
Yeah.
So flow rate is a huge thing on a heat pump. So if for example a 16 kilowatt heat pump, you need 44 litres of flow and you've only got half of that, you're only then delivering half of the heat output into the system. And that's when we hear about high running costs and consumers feeling cold, is because they've not got enough flow rate within the system. So weather compensation, all these types of things, it's not just about controls, it's about looking at the full system.
I'll just say, if anybody's got any questions or comments they'd like to ask, just stick your hand up, we'll come to you with a microphone. Does anybody have anything at this stage they'd like to ask? Or, well, if you do, then please stick your hand up and Heather will come to you with a microphone. There she is over there. So, okay. When it comes to designing the most efficient system for a customer, is there a process to go through? I mean, educate me. And if so, what is it? What is the process? Leah?
So the first thing is to actually visit the place,
Yep.
to look round the whole property, to look at the thickness of the walls, what all the different elements of the building are made of. One other really key thing is the air changes per hour. So there's quite a lot of debate out there about different methods of either measuring air changes or actually just taking the values from the SIBSI guide, which we are finding, because we're measuring quite a lot of our properties, are actually almost always massively over. So you really need to think not just about the fabric, but also the air changes. And then it's talking with the customer. Talking with the customer as well. What temperature do they like to run their house at? Are they comfortable having the heat pump on the whole time overnight? What sort of setback are they looking for? How much hot water do they use? Are they kind of sort of 5 people in the house all having a rainfall head shower every morning? You know, you really need to look at all those different factors about the people that are actually living there. And when you've done the heat loss calculation, you also need to look at pipe sizes. So the difficulty with that is how deep do you go in a retrofit property? Because you might look at all the visible pipe work, you might lift an easy-to-lift floorboard and get an idea about what pipes are under there, but you don't know about Joe, who 3 years ago stuck a bit of push fit in kind of, 15 mil plastic that screwed up the whole 22 mil copper circuit that you didn't actually know about. So there's always got to be that little thing in your head that you can't fully see everything. But you do as much as you possibly can to get that right. You size your pipe work and then size your heat pump.
Right, Rhiannon.
I often talk about emitters with customers as well, and the timing for that, I think, because changing all your radiators in your house can be quite disruptive and expensive, but timing is everything, and I find myself saying that a lot. And, on a personal note, when we put my heat pump in, some of my radiators were really gross and had been for a while, and everyone dried their swimming stuff on them and bits were rusty. But it was timing. It was timing. So we just changed everything. And I think I always ask about that, because if somebody is willing to upgrade their radiators, you can run low flow temps and you can get real efficiencies. And that is always a really nice thing to sort of be able to talk about in terms of environmental and cost factors.
Right, brilliant. Richard, do you want to...
I think one of the sort of thing about the air changes that you touched on before is that when I did my house, so I did a self-built property, and we had an air blower door test, which is obviously very handy in existing properties as well, because like you said, the SIBSI air change rate, which I've found as well, is miles out. So, and that's in the bulk of the properties that go in. And Rob Berridge, he quite often says, the air change rate sort of like 0.5, in most occasions that he's experienced, which is a mile in a day versus 4 air changes per hour in, some bathrooms or whatever it might be, And I think some of the importance here is that, if you try and, what I found off watching some of the third-party monitoring, actually, like the heatpumpmonitor.org table, is that you find spring and autumn times, but actually once you accommodate for the defrost cycles of the heat pump, some of the houses aren't actually achieving temperature properly. So you've just got to be very careful in those situations that how you design that system and how you actually think about how the issues that might actually you encounter along the way as well, because you might actually size the heat pump correctly for the input, but if it comes to the point at which you have a lot of defrost cycles, especially on, if ground source don't suffer. I'm quite lucky because I've got a ground source heat pump, so I don't suffer with with those issues.
Right,
but if you have the and I was going to say a few of the guys out there, they're quite I think they struggle with the whole getting it perfect all the time. Do you know what I mean? Because they do their absolute best to make sure that they've got the most efficient heat pump, the most efficient size, because obviously if you pay for something that's too big, the customer's paying for that at the end of the day, and you don't get the jobs.
Size matters.
But it's one of those where you've got nowhere to go with heat pumps. Once you've got your design, you've literally got nowhere to go.
Were you going to say something?
Yeah, I was just going to add in, like with the defrost cycle, our climate's been quite unusual the last few years, where it's been quite wet and it's been extremely humid. So my dad's got a heat pump, so he phoned me up. He's like, "Oh, it's gone into. I've got plumes of steam coming off it." And I was like, "It's defrosting, Dad." But it being wetter isn't always better for a heat pump, because obviously it needs to defrost a lot more with the more humidity we've got. So having those open volumes available for defrost cycle are key on a heat pump. And we also, for a heat pump manufacturer, it's not just about the defrost cycle, it's also about getting the best efficiency out of the product. So we don't want the compressor coming on more than 4 starts within an hour. And there's a calculation you can do to calculate your open volume requirement, which is normally higher than the volumes that manufacturers stipulate from a minimum volume for defrost. But I think we need to factor in more in our heat loss calcs, our humidity. And if you look at a manufacturer's output table, it's normally -2 that the heat pump is performing its best. And as it then gets colder, it actually steps up in some cases.
Where I live on the top of a valley, and some neighbours live in the bottom of the valley, and they can't understand why there's such a disparity between the two locations, but of course it makes sense because they're in a kind of a microclimate where they are. Do you have any particular favourite software or tools that you use for calculation? There's a lot out there.
It's going to upset someone. Do you know what I mean?
Yeah,
well,
that's how you can.
I was going to say I'm going to support Rob Berridge because he's a friend, but he has the Heat Engineer software for heat loss calculation. So they developed that, so he's been part of that for a long time, and he's been sort of 7 odd years in that, and that's what I know a lot of the guys do use that, and it's been quite at the forefront of heat loss technology, and the calculations were very much up there. But obviously other tools have come on the market at the moment.
Are available.
Yeah, I mean they really are, and I think there's the HX2 now as well, and there's quite a few popping up on the market just to make installers' lives easier, because obviously with the design side, it takes a lot of time. If you're going to put the effort into this, I'm not on the tools anymore, and I'm quite thankful of that, because the amount of effort that these guys have to go into with the visiting the customer, all the design, picking the relevant products to actually go with the heat pump systems, because when you come down to the product level as well, it's not the products aren't the same. So the products we use for domestic boilers, they're not the same products that you kind of want to use for heat pumps, because then they have their own issues as well.
Yeah, go on.
I was going to say, I think I've probably used them all, and there's no perfect tool out there.
Right.
They all have their pluses and minuses. You can have spreadsheets that at least you have the granularity of data that you absolutely know what's going on in there, but they're time consuming. We've used HeatPunk a lot. The output on HeatPunk is really nice. It's pretty easy to use. We're now doing a lot of jobs where people are having extensions and refurbishments. We're working a lot of plans. H2X is amazing for being able to draw around plans. Because previously we were having to measure the plans and then enter the data into something else. We've used Rob Berridge's tool, Heat Engineer. I really like the tool. I'm not so fond of the report that comes out the other end. But it's horses for courses, really. You probably have to try quite a few and work out which one works best for you as an installer.
Rhiannon,
I was just
I'll
going to
come
say,
you
Rich, with you talking about like how much is required from the guys that are installing now. One of the things that I think has really been brought home this year to me is we are expecting too much from one person. Like, we've got to break this down into parts, you know. Manufacturers
There's
are
no
going to...
silver bullet, so to speak, that covers all.
No,
Right.
but I think, you know, someone who ends up designing can excel in their job, they'll do it well, and then they can pass something on to an installer who will excel in their job and do it well. I mean, and then maybe even pass on to a third party, somebody who's designed sort of all that paperwork that we know has to be done after an install.
Yeah.
And they can do that really well. But I think one person being expected to do all of these things well
It's not possible.
doesn't make for a good user journey.
Fair enough. Go on.
I think from we've got a manufacturer's tool which is called EHS tool. But if you're comfortable using a heat loss tool, that's fine. You can just basically kick in what heat loss you've got. But I think using a manufacturer's tool, ours kicks out the field set values that you need to put into the controller, and I think that's probably one of the calls we get most often into our technical is what do I need to program into the controller for my system setup. So having that on our tool, you basically select your system, 1 or 2 zones, what you're doing with your hot water cylinder, and it kicks out a spreadsheet with all the field set values for that system that you've designed. So that is key, as well as programming the field set values correctly.
I was going to ask, how much two-way communication do you have with installers? Because that's key. They're the people at the front line who are, you know, facing everything on.
So we have a great pre-sales department that will assist in any pre-sales inquiries, but with my area that I cover, I try and go out on site with customers. If I've got a new build development, I'll spend time with the installer looking at their first fix. But as much as I can do to assist, I think I wasn't very academic when I was growing up, and I went into plumbing because I was good on the tools, and I've got Dave actually over there watching, who I served my apprenticeship with, so I'm going to give him a wave. But I absolutely love doing stuff with my hands, and I think showing an installer something is a lot better than actually learning it and having it in a class. And there's great online modules, there's great face-to-face training, but actually having a buddy on site that you can buddy up with is for me the best thing, is actually physically someone showing you.
Yeah. Dave, good apprentice or not? Thumbs up, that's good.
Thanks, Dave.
Thanks, Dave. Give you the money afterwards. But any other comments anybody wants to make about that in terms of what manufacturers can do to help? Go on, Leah.
For me, it's all about what support you give to your installers when it goes wrong, because stuff fails, stuff breaks, everybody makes mistakes. Installers sometimes make mistakes.
Yeah.
Manufacturers, or people who are putting kit together in factories sometimes make mistakes. So, what are you there for your installer when the chips are down? Because I'm the one with an angry customer who doesn't have any heating, and they're looking at me to sort it out.
You said we should use this, and it's not working.
Yeah, exactly.
Why
because
not?
I have recommended them a specific heat pump. So, and also I don't want a manufacturer who turns up and kind of invents things that we haven't really done wrong, but they reckon we've done wrong on the install. And that has happened. I'm not naming any names, but
Do it. No, joking, don't.
If you're a manufacturer and you get there and you think we've done something wrong, come and talk to me first. Don't go and tell the customer. And that has happened, and it's awful.
Where there's a blame, there's a claim. Otherwise,
please don't do that. So it's just remember your installer as a person there at the sharp end. And some manufacturers are good at this, and I'm being diplomatic.
Yeah, fair enough. And look, coming back to what you were saying, really about discussions on training, obviously really important. What training do installers need and want?
I was going to say I would do a third-party training course and then look at also doing the manufacturer's training. So if you're liking a product or
completely objective training
so you do something overarching, but then make sure you do the manufacturer's training, because that runs through the specifics of that product on what the manufacturer is looking for.
Yeah, absolutely. And at Warmur, we joined with Kimbo, and his Northampton Heating Academy is now Warmur Academy, and it is an absolutely brilliant course. And I think most people who have done it, often people do it more than once. I've done it twice. You get a real experience with Kimbo as well. You never know what he's going to say, but he really does know his hydronics. And I think sort of people come out of that course with a kind of, pull back the curtain, really figure it out, and he gives you the tools that when you're on the job, something's not working, you've got that understanding and you can figure it out, basically.
Rhiannon, if I didn't know you better, I'd think that was a subtle plug for Kimbo. What am I going to say? Go on, Richard, do you want to get a comment?
Well, Kimbo's a mate, so I was always going to promote him anyway, David, to be honest. But no, I think the key things from whatever training you do is that once you have a general understanding of how flow rate works, how pipe sizing works, how heat loss works, you've got a very good chance of getting the install right. But you still, that doesn't, the problem is everything's perfect in a perfect world, right?
Yep.
So retrofit market is a really difficult world to do that in, because you don't know exactly what's there or what you're going to encounter. So there is a little bit of variable and a little bit of guesswork that goes into retrofit, unless you strip it all out and start again, which a lot of people do. So as far as the training goes, just like I said, Kimbo's course, that would always be my first recommendation. Obviously, there's other third-party providers out there now. I won't name any because there's too many popping up now and I'd be biased. But as long as you get the Kimbo training done, and then he normally recommends half a dozen other training providers and things like that. So get that done under your belt.
Go on, Rhiannon, were you just going to
I was going to say, there are other training providers, and I do think, like, as an industry, like, we're starting to take this kind of math seriously, and that this kind of planning needs to be done, and this kind of, even if you end up using someone else to design, a third party in the design process, because I know manufacturers can even provide installers with design.
Yeah.
Even if you've got this basic understanding, that means if something happens and it goes wrong, you know when something doesn't feel right.
We've got time for any questions, if anybody wants to ask a question as well, before I come on to the final question or comments from the panel. Anybody at all? Any comments or questions? You can always grab these people afterwards, I'm sure, as well. I just want to ask you generally, actually, I think you've all been to this show before, is that right? What's your impression of what you're seeing? Because it's grown quite a lot, hasn't it?
Yeah, it's definitely grown from the years I've been coming to it. So I think it's Samsung's second year at the show, and it's great seeing familiar faces and customers and old colleagues as well.
Because I was going to say, for installers, I mean, it's your only chance, one of your only chances in a year to actually meet up and see people face to face. So that's a great opportunity, isn't it?
Yeah, there was definitely a real buzz before the show. People saying, kind of see you at installer. Although I did see a funny comment on LinkedIn. Somebody wrote, "Too many heat pumps." So I think we're doing something right.
Year by year, it's grown on the heat pump side. I first came 3 years ago and was completely overwhelmed by everything, because it was just like, wow. And I was fairly new in the industry. Last year, a step up, and this year, a step up again. I think it's a brilliant, brilliant event.
Brilliant. Final question. I'm not getting political, but we've got a new government from Friday next week coming in. How do you think that's going to affect policies and so on and so forth that have been signed up? Yeah, you're giggling.
What am I expecting? Not very much.
Yeah.
What would I like to see?
Yes.
The first thing that really needs to be done is to sort out the imbalance between gas and electricity prices. It's like an absolute no-brainer, because we're selling a super efficient system, but we're telling people it costs them about the same to run because of the price disparity. So find a way to fix that, and a lot of other stuff falls into place.
I was going to say, I was thinking about SCOPs and efficiency, and we've got some heat pumps on the market now that are doing 65 degrees, and they're providing SCOPs of 2.8, and that's kind of, the 2.8 is the break-even point with gas. If we can collect, do you know what I mean, increase that, then it's going to be, heat pumps will work at higher flow temperatures. They're not as efficient, but it's exactly the same as a gas boiler. So having, do you know what I mean, cheaper electricity prices will only drive, I think, the heat pump market.
Will it cost me more? That's what I always hear. Will it cost me more?
Yeah.
And with a good install, obviously not. But with that change in spark gap would be a total game changer. I'm not overly hopeful either. But I think we need to do things from the ground up. We need to do things despite government and policy changes, if they come.
Because they're always going to be there in one form or another, aren't they?
Absolutely.
I mean, the big problem with government anyway is whenever a new government come in, you don't exactly know what they're going to do.
Neither do they.
So exactly. I mean, well, I think first of all, you've got to look at things and the actual purse pot that's there, yeah? Because we can't keep giving out grants out of thin air, yeah?
Yeah.
So we've been here before, right?
Yeah.
Early 2010s, new government changed a lot of things. Didn't exactly pull the RHI, but they certainly made it lesser than what it was proposed to be, right? So I am hopeful, but government have got
Don't hold your breath.
Government have got a way of wrecking things sometimes, right?
Yeah.
I hope not, because obviously with the green industry that is clearly growing, that's something we all want to be a part of, right? So,
yeah, but
it's still in very early stages. Still needs grants and subsidies. There's not enough people out there that actually want to change the world.
And
right?
we see target dates slipping and changing as well. I mean, you know, who knows? Go on, Rhiannon, you were going to say.
What was I going to say? I was going to say, I do worry about gas companies lobbying government straight in. You know, day two, you got your feet under the table, new desk, and now
Boom.
I worry about that,
Yeah.
and I worry about who's going to lobby the government on behalf of heat pumps. And you know, you've got to play the game. It's not me. I don't know anything about it, but that's the sort of thing I worry
Brilliant.
about.
Well, we'll see. We'll see from, as I say, 8 days' time. My final question is, where did you get the jacket?
Lovely company called Festival Heaven.
Brilliant. And have you got shares? No, we won't go there. Listen, thank you so much. Thank you to all of you for joining us, Aimee, Leah, Rhiannon and Richard. And as I say, if you're around, if you want to ask questions, too embarrassed to ask them in public, then come up and ask these lovely people now. But please give them a round of applause. Thank you very much.
Thank you.
Indeed. Just as we've got Pavarotti coming in the building, it sounds like, I don't know. Thank you very much, Lee. Thank you.